Namaste and welcome to my channel Civil Laces. Here I am with 5th video tutorial on building analysis by Etabs. In this videos we are talking about assigning the loads in our modeled building. If you haven't watched my previous videos, you really should to know more about the building analysis. And I request you to subscribe our channel for more future videos. Okay, the main process of assigning the loads is we have to select the specific component, for example beams or the slabs, and we have to go onto this assign tab through which we apply the loads on a specific element. Before assigning any loads, let's talk about the load paths in framed structure. This is the simple sketch which shows the components of the framed structure, example floor slabs, beams, columns and the foundations. Live loads and superimposed dead loads act on the slab, which in turn transfers to the beams, and it transfers to the columns, and finally it transfers to the foundations. Superimposed dead loads on the slab are the loads due to the partition walls which are resting on the slab, loads due to the furnitures inside the room, and many other dead loads on the slab. Let's talk about the loads on the beam. Loads that you have previously applied on the slab are automatically transferred to the beams by Etabs. You don't need to do anything for that. Most main walls and the partition walls rest directly over the beam, and we have to assign the loads due to them on the beam. Let's see the plan of building. Here in this plan, this tick mark indicates the main wall without opening. You can see here there is not any opening. Similarly, in this beam there is also main wall without opening. Here is also the main wall without opening. And this cross mark indicates the main wall, that is main wall is 9-inch wall with opening. You can see here is the opening. Similarly, this cross mark also indicates the main wall with opening. And this minus sign indicates the partition wall. Partition wall is the 1/2-inch wall and here is not opening. So this minus sign indicates the partition wall without opening. And this small box sign indicates the partition wall with opening. You can see that here is the opening. Similarly here is a partition wall with opening. You can see that some walls are not resting on the beams. For example, this is the partition wall which is not resting on the beam because there is not any grid. So the loads due to these partition walls are applied to the slab in this frame. We will know more about this in the later. Let's move to some prior load calculations. We know that load equals to the unit weight of masonry into volume. And load due to main wall of 9-inch on the beam equals to width of wall into height of wall into masonry unit weight. Here we have the 9-inch wall, so I convert it into the centimeter by multiplying by 2.54, that is 1 inch equals to 2.54 centimeter. I divide it by 100 to convert it into the meter, and floor height is 3 meter and masonry unit weight is 20 kilonewton per meter cube. Load due to main wall is equals to 13.72 kilonewton per meter. Here in this plan we don't have the exact dimensions of the height of opening, so we can't reduce the weight from the opening. Thus I assume that the main wall with opening load is about 70% of main wall without opening. So loads due to the main wall with opening is 0.7 into 13.72 equals to 9.6 kilonewton per meter. I assume the 30% reductions by the opening because we don't have the exact dimensions of opening. We don't have height, we don't have this length in our plan, but if you know the exact dimensions of opening, that is length, height of the opening, then you can reduce by calculating the weight due to the opening. I assume the 30% reductions by opening. We also have the partition wall of width half of the main wall. So the exact loads from the partitions wall will be half of this value because everything is same except this width, that is we have 4.5-inch partition wall. Thus the load due to partition wall without opening is 0.5 into 13.72 equals to 6.86 kilonewton per meter. And we also have partition walls with opening. We don't again have the opening dimensions in proper, so I assume the partition walls with opening is 70% without opening. So again partition walls with opening load will be 0.7 times this 6.86, which is equals to 4.8 kN per meter. This is IS 875 Part 2 code, which gives you the values for the live loads. Here we are designing the residential building. So for the residential building, all rooms, toilets and bathrooms, the live load should be assigned to 2 kN per meter square, and for the corridors, passage, staircases and balconies, live load should be 3 kN per meter square. So far we discussed about the load paths and magnitude of different loads, that is main wall loads without opening, main wall loads with opening, partition wall loads without opening, partition wall loads with opening. Now we are going to assign loads to the building. For example, if I select this beam and assign a specific load, that is loads due to the walls above it, and if I am working in all storage platform from here, and if I specify the certain main wall loads, then the loads will be assigned to the beam of every storage, that is to this beam, to this beam, to this beam and to this beam also. But you can see there comes the wall above these three beams, that is this beam and this beam, but there will not be any walls above this beam, but loads have already been assigned to this beam also. Thus that's not happen. If you see here, these three floor, that is first floor, second floor and the third floor, are similar in geometry and similar in loading way also. You can rotate this 3D view by using this rotate icon, for example in this way. So if you see this fourth floor, it is geometrically similar to this other floor, but there are not walls above the beams on this floor, so it is not similar in loading way. Thus what should we require is, if I am assigning a load to this beam, then same load should be assigned to the first floor beam, the second floor beam and third floor beam, but not to this floor beam. For that we work on the similar storage concept. So let's talk about what is similar storage. To know more about the similar storage, go to this edit tab and then to the edit storage and grid system, and then click on this modify show story data. Etabs allows you to design it any story as a master story and then identify other stories as a similar. If I assign a first floor as a master story, for example here in this master story column, if I assign this first floor as a master story, and I have already said that the first floor, second floor and third floor are similar in geometrical and in the loading way also. So and I assign this second floor and third floor similar to the first floor, and click OK. Here is also OK to exit. Now if I select any beam of first story, then all the beams of second story and third story are also selected. So this is what we need. If I assign a specific load to this beam, then the same load will be assigned to this beam also and to this beam also. This reduces the time to draw and assign the loads. Let's first deselect it. For this to happen, you have to work in similar storage platform. If you work in all storage platform and you select this beam, then all the beams will be selected. So you have to compulsorily work on similar storage platform. I'm again going to show you, if I select this beam, then only these three beams are selected, because the first floor is our master story and the second and third floor refer to the first floor. The ground floor and the roof floor can never be the master story, because in the ground floor there will not be any reinforced slab, and in the roof floor there will not be any loads above them. So ground floor and the roof floor can never be the master story. You can see from here, edit storage and grid system, modify storage data. You don't have any option of selecting ground floor as a master story. So we have already selected first floor as a master story and other two, second floor and third floor, as similar to the first floor, because it reduces time and it helps us to assign the load easily. Okay, click OK to exit. Now we can move forward to assign the load. For this we have to refer to the plan. See the plan again. You can see here there is a main wall above this beam, and again this and these. So they have the right tick, and I've already mentioned that there is not any opening on the walls above these beams. So we first select these beams and assign the load to them. Okay, let's select this beam which carries the wall without opening. And for this, go to the plan to confirm. I'm going to select this beam, this, and this, because they don't have any opening. So select, make sure that we are working on similar stories. Select this beam. After selecting these beams, go to the assign tab to assign the load. And these are the frame loads. Go to the frame loads, and we are going to assign the distributed load. So go to the distributed load. The loads due to the walls will be distributed load, uniformly distributed load. And load pattern name, we have already named our load patterns in define tab. So click here to expand and click main wall load. Selected beam carries the main wall without opening. So let's refer to the magnitude of the main wall load without opening. You can see here, load due to the main wall of 9 inch on the beam equals to 13.72 kN per meter. Type here 13.72 Newton per meter. Apply and OK. You can see 13.72 kN per meter load has been applied to all the beams from first floor to the third floor because they are similar. This is the second floor. I'm navigating to third floor, and you can see the loads have been applied. There is not any loads on the roof. This is the extruded 3D view, and not to make it extruded, go to this option where you can see the extruded view toggle and click it. You can see here now the extruded view has disappeared. To again make it to extruded, you just can click this, and again it is extruded. To see the applied loads on the 3D view, make it non-extruded at first through this tab, and then go to the display tab, and we are going to see the assigned load. So click on load assign, and frame, we have previously assigned the frame loads to the beams, so click on frame. The load pattern is main wall load, which is OK, and click apply and OK. You can see here, you can rotate it by using this option to see the loads. So you can see here the selected beams have been assigned the load of 13.72 magnitude from first floor to the third floor. Thus assigning the load is a very simple task. Again rotate it, and to see the extruded view again, or to see the original 3D view, you just go to the display and click on undeformed shape and make it extruded by using this tab. This cross-marked sign indicates the main wall with opening. So select the beams on the Etabs model exactly at these cross-marks beams which carries the main wall with opening, and assign a specific value of the load to them. So basically this beam here, this beam, and this beam. Go to the Etabs model. These selected beams, this beam, this beam, this beam, and this beam have the cross-marked sign in plan. You can see here. So I have selected them. Now I'm going to assign a load. For that, I have already selected, so go to the assign tab, and then the loads on the beam will always be the frame loads. So click on the frame loads. Loads due to the wall are uniformly distributed wall. Click on the distributed load. This also comes under the category of main wall load. You don't have to define the main wall load without opening and with opening in load pattern name, because that doesn't make any differences in analysis. So click here the load of 13.72 into 0.7. I have already said that I assume 70% of the load of main wall without opening is equals to the main wall with opening. Click apply and OK. You can see here the loads have been applied from the first floor to the third floor of selected beams. This wall rests on this beam, so if I select this beam in the Etabs model, I have to assign a load, and this wall is 4.5 inch, that is partition wall. So it contains the opening also, so I have to assign a load of partition wall with opening. Similarly, you can see that this beam also contains the partition wall. This wall, partition wall means 4.5 inch wall simply. So this is the 4.5 inch wall, and here is also the opening. So the beam on these positions also contains the partition wall, that is 4.5 inch wall with opening. I'm going to select it on the Etabs model. Select this, make sure you are working on the similar storage platform. Select this and this and this. See the word file here. Loads due to the partition wall with opening is equals to 4.8 kN per meter. Go to the assign tab, frame loads, distribute it, and this is the partition wall load. Click here 4.8 kN per meter. Apply and OK. After applying this load, the other loads have disappeared. Etabs only shows the specific load patterns on its positions. The loads have just been disappeared, but they are still assigned to these beams. This beam contains the partition wall without opening in plan. You can see here, this is the partition wall without opening. So select this, go to the assign tab, and then frame loads, distribute it, the load due to partition wall without opening is 6.86 kN per meter. Apply and OK. Now let's apply the load to the slab. Select these slabs, go to the assign tab, and the slab comes under the category of cell loads. So click cell loads and click uniform. So I'm assigning the live load, and the live loads of all the rooms from IS code is 2 kN per meter square, except for some passages and balconies. I apply and OK. So now it is replaced to 2 kN per meter square. Let's add another load, that is surface finish loads. We haven't defined the surface finish in define tab, so let's define this load. Go to the define and then load patterns, and here surface finish. Click to add new load and OK. Now to select all the previously selected slabs, you can just click here to PS all, get previous selections. Previous slabs are selected. Go to the assign tab and cell loads and uniform. This time the category load pattern name should be surface finish. Let's apply the 1 kN per meter square as the surface finish load. Apply and OK. To see the loads have been replaced or just remain, to confirm, click on the display, load assigns, cell loads, and choose the category of live load 3-. Apply and OK. You can see the 2 kN per meter square load has been still applied. Let's select this staircase slabs. Go to the assign tab and then again cell loads, uniform, The staircase slabs have the live load of 3 kN per meter square, so I select the live load 3 plus and then 3 kN per meter square. Apply and OK. Here are the some walls, for example this partition wall which rests on the slab. So the load applied by the partition wall which rests on the slab is converted into the kilonewton per meter square. That is, we calculate the total load, that is unit weight of masonry into height into width into length of the masonry wall, and then we divide it by this panel of slab and we apply this load to this slab. Just for the example, I am calculating this load and apply this to this slab. So for calculating this load of wall, partition wall, belongs from this point to this point. So the distance between these 2 points is 1.143 plus 2.4638. This is the length of the partition wall. 4.5 is the width. 4.5 inch is the width of the partition wall. I multiply by 2.54 to convert it to the centimeter and divide by 100 to convert it into the meter. 3 is the floor height. 20 is the unit weight of the masonry, and I multiply this whole result by 0.7 to get the result of partition wall with opening. So it comes 17.31 kilonewton. Now that partition wall rests on the slab, so loads on the slab equals to the 17.31 kilonewton divided by area of the slab. 17.31 divided by 3.6 into 3.58. This is the area of the slab. 3.6. This total length is 3.6 and 3.58 is breadth. So it gives the value of 1.343 kilonewton per meter square. Let's assign this load to this slab. Select this slab, go to the assign tab, click on the cell loads and uniform. The load pattern should be, this is the load due to the partition wall, so partition wall load, and the load should be 1.34 previously calculated. It's a gravity, and click apply and OK. So 1.34 kilonewton per meter square has been applied under the name of partition wall load. In this way you can assign the loads to the wall. So I have assigned every loads from the first story to the third story, but in this fourth floor or fourth story I have to assign a different load. So I go to the fourth floor by navigating through this tab. Now I am on to the fourth floor. This beam carries the main wall load and this beam carries the partition wall with opening. So select this beam. I just escape it. Make sure you are working on one story because we are applying the loads in this story only. Click this beam, go to the assign tab, and then frame loads, distributed. It comes under the category of main wall load. 13.82 something. Apply and OK. Click this, assign. This all recently selected slabs comes under the categories of balconies or terraces, so they should be assigned the load of 3 kilonewton per meter square. Go to assign and then cell loads and uniform, live load 3 plus cell, apply and OK. So they have been assigned the 3 kilonewton per meter square loads. Similarly, we have to assign the surface finish loads on them. Click this, assign, cell loads, uniform, click on surface finish and 1 kilonewton per meter square is the surface finish loads. Apply and OK. Let's go to the roof floor. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . that is roof cover, and let's apply the surface finish loads only, because there will not be any live loads or there will not be any other loads on the roof, because there will not be any things on the roof. If you have thought of assigning a water tank load on the roof, then you should define the water tank load on the defined pattern name, and you should assign the water tank load on this slab. But we haven't done anything for that, so we just assign the surface finish loads on this. Select here and then go to assign cell loads, uniform surface finish of 1, apply and OK. Navigate it to the roof view. Now we are left with assigning some parapet wall loads, because we apply the parapet wall on this terrace. Select all the beams on which the parapet wall rests. This beam, sorry, this beam has already been assigned as a main wall load because there will not be any parapet wall. So all these other external beams contain the parapet walls. Go to assign tab and then frame loads, distributed. The load pattern name should be parapet wall load, and you can easily calculate the parapet wall load in terms of kilonewton per meter. For 1 meter height of the parapet walls and for 4.5 inch brick wall, the load will come as a 2.286. kilonewton per meter. Click apply and OK. So basically we completed assigning the loads to the beam slabs. Now we are left with assigning some we are left with assigning the staircase loads to the beams. So we will make it on another video, assigning the staircase loads on the beams. So this much for the today's video. Please subscribe our channel to know more about Etabs tutorial. Thank you.